Morning, folks. Thanks, Randy, for the KBMP updates, particularly that data visualization stuff, and just keeping us all abreast of the organization's efforts and role in water quality monitoring support in the basin. And while we're not in person, Randy's done a great job, as well as the steering committee, to develop these 11 talks that I hope you'll find enjoyable. For this first morning session, we have Shubham Tiwari, Maya Singer, and Brian Tilt. Shubham will kick it off. He's from UC Davis. He'll start the session presenting work completed in the Scott Valley. His talk is titled Balancing Agriculture with Groundwater-Dependent Streamflow, a Hydrologic Framework for Economic Decisions on Irrigation Curtailment and Land Restoration Strategies. Welcome, Tiwari.
Thank you so much. Let me share my slide. Hi everyone. I'm Shubham Tiwari. I'm a postdoctoral scholar at UC Davis. And so today I will be presenting balancing agriculture with groundwater-dependent streamflow. And in this study, we have developed a hydrologic framework for economic decisions on irrigation curtailment and land restoration strategies. And this study has been conducted with collaboration with the Nature Conservancy. So give me a minute. Yeah. So about the Scott Valley watershed, yes, you can see in the Scott Valley, the main challenge is reduced summer flow and delayed fall reconnection. So the key causes behind these challenge is groundwater pumping and surface water diversions and the climate change also. So this red dot here is showing the downstream USGS gauge in the Fort Jones, where the stream flow data has been collected. And the graph here at this point is showing the stream flow monthly average data at the Fort Jones gauge. This black line in this graph is representing the stream flow, monthly average stream flow, and this dark gray pocket is showing the median flow, 50% median flow. That means 50% of the time the stream flow remains within this range, and this light gray pocket is representing basically the 90% median flow. That means 90% of the time the stream flow is being within this range. And here this blue line is representing the CDFW recommended flow in the Scott River, and this red line is basically showing the emergency recommended flow from CDFW. As we can see in the summers, the average stream flow in the Scott River goes below the recommended CDFW stream flow. So in this study, what we have done is we have simulated the water conservation management scenarios for the Scott Valley using this framework. And in this first scenario is about the irrigation curtailment, where we have conducted the closure of irrigation after the second cutting of alfalfa. And another type of scenarios which we have looked is land repurposing, where the farms with alfalfa and pasture are replaced by less water consuming crops or native vegetation. So the main question in this study was, which are the most suitable properties, or let's say farms, in the Scott Valley for irrigation curtailment and land repurposing to achieve the improved stream flow conditions as measured at the Scott River Fort Jones gauge that is in the downstream of the Scott River. So for this study, we have used a Scott Valley integrated hydrologic model. That short form is called SWIM, and this model is developed by Professor Thomas Harter and his team. And I will give a small brief about this model, that this model has three components, where first component is stream flow regression model, which basically takes care of the mountain front recharge as well as the snow melting. And then second component is soil water budget model that takes care basically soil land use processes. And then third one is groundwater surface water model. And all key components are integrated in such a way that we can simulate the Scott Valley hydrologic processes. So for this study, we have considered a 30-year model period starting from water year 1991 up to 2021. So basically, this is how this model provides the results, the monthly average stream flow. So these color lines here are representing the main Scott River and its tributaries, and different colors are basically showing that how much amount of stream flow is happening at any point of Scott Valley, main Scott River or its tributaries. And we have taken the average of all these 30 years. Basically, the model provides us daily amount of stream flow at any spatial point in the Scott Valley, and then we take the average of these. So this is how we have taken the stream flow calculation for this study. So our first objective for this study was to analyze the effect of irrigation curtailment on the watershed outflow, which is at the Fort Jones gauge. So irrigation curtailment, that means the closure of irrigation after the second cutting of alfalfa. And we have assumed that up to the 15th of July in the Scott Valley, the second cutting is being done. And then the irrigation, the groundwater or the surface water irrigation will be closed. And for analyzing, we have taken these 6 scenarios in this study. The first one is the farms which are in the upper Scott Valley, then farms in the mid Scott Valley, lower Scott Valley, Reach 9 farms. We have also taken 2 more scenarios that are 5 largest farms by irrigated acreage, and then we have considered the 10 largest farms by irrigated acreage. Basically, the idea was not to close the irrigation throughout the valley, but take the group of farms at different point of the valley, and just to analyze that which part of the valley is most sensitive towards the irrigation curtailment and where we can achieve our objective. So when we have simulated using the swim these scenarios, here are the results. Here are the few results, and the right-hand side graph. How to read this graph? First of all, the red dotted line here is showing the minimum flow rate, that is 20 CFS, and this blue line, let me take the laser here. Yeah, so this blue dotted line here is basically showing the base case scenario where we have not applied any irrigation curtailment. And then these solid lines are basically showing the impact of the irrigation curtailment based on different type of scenarios which we have selected. So from the simulation, what we have obtained that in the summer, if we apply this irrigation curtailment after the second cutting of alfalfa, we can achieve up to 10 CFS increment in the summer stream flow in Scott Valley. So we have obtained that when we consider the 10 largest farms, then 5 largest farms, these are the maximum effective scenarios, and then farms in the mid Scott Valley will be very effective. And moving forward, other than that, we also have looked the seasonal impact of irrigation curtailment. So we have looked the average precipitation year, then wet years, and then dry years. And we have looked the impact of irrigation curtailment in this group of years. So what we have found that looking at the average precipitation years, you can see that impact of the irrigation curtailment in these years is very significant. It's almost about 20 CFS. Similarly, for the wet years, because the y-axis is in the log scale, but the impact is very high. But now coming to the dry years, as you can see, in the dry year, the impact was very minimal, and it was like 1 CFS or 2 CFS in all the scenarios. So what we have found here was that irrigation curtailment was effective for the average precipitation year, wet year, but it was not effective in the dry years. We have also looked at the stream depletion reversal. That means that due to the curtailment, what is the gain or loss to the stream because of these scenarios? So in this graph here, in the left-hand side, is showing basically the increment in the stream flow at the Fort Jones gauge because of all these scenarios. So this 0 line is basically showing the base case, and then these increments are showing because of the different scenarios. So this top scenario is, I think, the top 10 farms collective, where the irrigation curtailment was applied. And we can see that in the summer, the increment in the stream flow because of this irrigation curtailment was obtained up to 15 CFS. And to normalize this, we have divided this stream depletion reversal with the area so that we can obtain that each of the scenario per unit area, how impactful those scenarios are. So we have given its name as a sensitivity factor. And looking at the sensitivity factor, we have found that these four scenarios in the right-hand side graph are showing the almost equal amount of sensitivity, that these four group of scenarios are very impactful. Those are like 10 largest farms, 5 largest farms, and the farms in the Reach Line and the mid of the Scott Valley. Along with this, we have also looked the impact of irrigation curtailment on the tributaries of the Scott River. So we have considered four different tributaries and done the similar kind of simulations by considering the properties near the French Creek in the first scenario, in the Shackleford Creek in the second scenario, then Etna Creek and the Patterson Creek and Big Slaw Creek collectively. And when we have conducted these scenarios, the impact in the summer months here in this table, as you can see, comparing the base case and after the irrigation curtailment, the impact was very small. And the reason behind this, because in the summers, these tributaries are having almost no flow. And although there is a curtailment, the impact is very nominal. But the absolute gains are very small, but such increment can also be ecologically meaningful. So we can discuss about this later. So this is about the irrigation curtailment in the Scott Valley. Now coming to the second objective of this study, that is analyze the effect of land repurposing on the watershed outflow in the Fort Jones gauge. So here, what we have done, as I have already explained about the land repurposing, the farms with alfalfa and pasture, because those require higher amount of irrigation, are being replaced by less water consuming crops or native vegetation. And we have simulated these scenarios, these two scenarios here. One is long root profile vegetation, where we have considered that native vegetation with the root depth of 8 feet, and then another is native vegetation with the root depth of 3 feet. And we have looked the impact only for the 5 largest farms. So when we applied these, changing the alfalfa and pasture with these native vegetation having 8 feet root depth and 3 feet root depth and non-irrigated irrigation status, what we have found here. So this graph here is representing the monthly average flow rate at Fort Jones for by taking the average of these 30 years. And here in this graph, again, this line, red line, is the minimum flow rate, that is 20 CFS. And this blue dotted line in the bottom is representing the base case. And this red and green line are representing the impact of land repurposing, where we have changed the alfalfa and pasture with the native vegetation. And we have also compared this with the impact of irrigation curtailment, that the line in the light blue in between. So the irrigation curtailment, because if we conduct irrigation curtailment after the second cutting of alfalfa, we can achieve the increment in the Scott River stream flow by 10 CFS. But if in the same property, if we apply the land repurposing, we do the native vegetation in the same properties, we can achieve almost 30 CFS of gain. So we can see here that land repurposing is more impactful in comparison to irrigation curtailment for the same properties. And when we looked at the seasonal impact, as I have already discussed about irrigation curtailment, that irrigation curtailment was not effective enough in the dry years. But when we looked at the impact of land repurposing or changing it with the native vegetation in the same properties, here It seems a significant increment in comparison to irrigation curtailment. So here you can see it's about 1 CFS increment because of the irrigation curtailment. This line here, this light blue line, it's showing the increment because of the irrigation curtailment, but this red and green line again is showing the increment about 7 to 8 CFS in the summer months. So land repurposing is providing the increment in the summer base flow. Along with that, it's also giving us the spring recession delayed by 2 weeks, and the fall reconnection occurs 1.5 weeks earlier. So this is the impact of land repurposing in the Scott Valley. Then coming to what is happening within the aquifer due to these scenario simulation of irrigation curtailment and land repurposing scenarios. So we have looked at the aquifer budget of our model, and we have found that while comparing, we have found that the curtailment and repurposing reduce the groundwater withdrawals, of course, because we are closing the irrigation, and evapotranspiration, but it slightly lowered the recharge and reduced the late season stream flow losses. And that's why we are seeing these kind of impacts by using this kind of scenarios. So the key takeaways from this study were land repurposing and irrigation curtailment strategies are effective enough to increase the average monthly flow rates at Fort Jones gauge by looking at these 31 year of simulation period. And the land repurposing strategy is more effective than irrigation curtailment for these 5 largest irrigated acreage farms, which is about 20 CFS increase during the dry months versus 8 CFS from irrigation curtailment. And then in the dry years, mostly the main point is in the dry years, the land repurposing strategy has a substantial impact on the flow rates, while irrigation curtailment is less effective under the drought condition. However, irrigation curtailments are more economical than land repurposing. And finally, these scenarios compare the hydrological outcomes. We do not take into account the diverse stakeholder values, economic consideration of local economy downstream interest parties, or we have not predicted the ecological outcomes. That is our future scope for this study. I would like to thank you.
Great, thank
So,
you,
yeah.
Shubham. Anybody have any questions at this point in time? And I can't see any hands raised or stuff like that, so I'm gonna have to rely on somebody else to
I have a
manage
question.
that. Go ahead,
Yeah.
Mike.
So when you say land repurposing, maybe I missed you exactly what that really entails. Is that just planting a different crop, like say going to grain, or and I apologize, you probably explained it in there, and I just missed it. Long root
Yeah.
profile. Okay, I saw that, but is that just like ripping out the alfalfa and putting in a different, like say irrigated or non-irrigated pasture? I mean,
Yeah, so basically in this study, we have not conducted a very depth analysis about like which kind of bunch grasses or shallow native vegetation we are planning to introduce as a native vegetation. We have just like taken the long root profile and short root profile based on like different studies conducted in the California that what kind of native vegetation root depth is there. But yeah, that could be like further process for the study to look at by identifying that in California or in the Scott Valley, what kind of native vegetation we have to approach for
okay.
this kind of approach. Yeah.
Would would it be possible to analyze something like going to winter wheat or grain that's non-irrigated instead of non-irrigated pasture? Would that be possible?
Of course, yeah, that's a good question, and that's what we are targeting about. Like in the Scott Valley, if we look at let's say changing the let's say replacing the alfalfa and pasture with the grains. Uh, Yeah, it is possible. Like if we provide different type of extension depth or root depth and KC values to the model, we can simulate any kind of scenario using this model. Yes.
Thank you so much. Great presentation.
Thank you so much for
Great.
your question.
Great. We have a question in the chat from Laurel Ganzoli. Can you explain a little more about the mechanism for curtailments being less effective in dry years?
Yes. So based on the aquifer budget, what we have found that basically in the dry years, the stream flow and the groundwater level, they are basically disconnected. And when it goes disconnected, the water table is very down and it goes disconnected. And even though we are applying the irrigation curtailment, and we are not using the groundwater because of this irrigation curtailment, this connection is not happening in the dry years. And so that this impact on the stream flow is not showing, it's not we cannot achieve this impact on the stream in terms of a stream flow because there is no connection between the groundwater and stream flow. This is what we have obtained from our aquifer budget.
Great. Thank you. Are there any other questions, comments right now?
I just have a question real quick, Mike, a follow-up to that on Laura's question.
Mhm.
So when you're analyzing that disconnection between groundwater and surface water in dry years, did you look at that in your different reaches that you have established throughout the Scott, and were they all uniform in that disconnection, or are there certain areas that might be curtailed that we would get a response in a drought and other years where we wouldn't?
Yes, so yes, of course, because this connection and disconnection things is not happening throughout the Scott Valley. It's like more part of the more because this model is like cells of 100 by 100 meter cells. So few cells are like if we say in the average year or wet year, more cells are connected in the summer season. But when it's a dry season, more cells are disconnected. So it's not throughout the valley, but up to now, the scope of this study was like looking at throughout the valley, just on the Fort Jones gauge. But this is a very good observation. And if we have any future scope of looking at some specific reach, yes, we can look that point also for using this model results. But up to now, the scope of this study was like looking the impact on the Fort Jones specifically.
Great, thank you.